guys, welcome to the channel. So today we are going to talk about Charles law. Okay, Jack Charles in 1787 studied the quantitative effect of temperature on the volume of the gas of mass of gas at constant pressure. So keeping the pressure constant, keeping the pressure constant, the scientist named as Jacques Charles in 1787 AD study the quantitative effect on the volume, okay, which shows that volume is directly proportional to temperature. Effect of temperature on the volume. Summarize the result in the form of Charles law, and he summarized the result in the form of law known as Charles law. So what does it mean? Charles law studied an effect between temperature on the volume of the gas, keeping the pressure constant, and he find that volume is directly proportional to temperature, which means if the temperature of a body increases, then its volume also increases. Let's move to this statement. At constant pressure, the volume of given mass of a gas increases or decreases by 1 by 273 of its volume at 0 degree Celsius centigrade for every 1 degree raise or fall in temperature. This statement means if we keep the pressure constant and keep the initial volume and let the initial volume be VO and at the temperature 0 degree Celsius, and when we increase or decrease the temperature, then it will increases or decreases the temperature by 1 by 273 of its initial volume at 0 degree Celsius, which means uh, which is also given here. We can know from here. So let's go to the explanation. Let VO be the volume of a gas at 0 degree Celsius. The volume of a gas at 0 degree Celsius is VO. When the gas is heated, according to the Charles law, when the gas is heated, temperature also increases because heat is directly proportional to the difference of temperature. Volume of a gas at 0 degree Celsius is VO. Then volume of a gas at 1 degree Celsius will be VO plus 1 upon 273 times VO, which is also given in the statement here. The volume of given mass of gas increases or decreases by 1 by 273 of its volume at 0 degree Celsius. And our volume at 1 degree Celsius becomes VO bracket 1 plus 1 upon 273. Accordingly, volume at 2 degrees Celsius becomes VO plus 2 upon 273 VO, and we can write it as VO plus 1 upon 273, and the volume increases according to when increasing temperature. Now finally the temperature becomes 273 degrees Celsius. Then at this condition, the volume will be 2 times of its initial volume at 0 degrees Celsius. Okay, so the gas is double when the temperature increases from 0 to 273 degrees Celsius. Okay, now let's prove V is equal to, let's prove the Charles law, which is, what is Charles law? V is directly proportional to temperature. Okay, let us consider V1 and V2 be the volume of a gases at T1 and T2 degrees at Celsius temperature. Volume of gas at small t1 degree Celsius, V1 is equal to VO bracket 1 plus T1 upon 273. Let's take it as equation 1. Then volume of a gas at T2 degrees Celsius is VO bracket 1 plus T2 upon 273. Dividing 2 by 1, we get 1 plus 2 T2 upon 273, 1 plus T1 upon 273, and taking the LCM, we get this. This is equal to temperature in Kelvin scale. That here T2 is temperature in degree Celsius, and when 273 is added to the temperature in degree Celsius, then the temperature will become temperature in Kelvin Celsius, and the capital T denotes temperature in Kelvin, temperature in Kelvin, which is written here. T is temperature in Kelvin, and relation is degree Celsius is equal to 1 degree Celsius is equal to K minus 273. Now we can write it as V1 upon T1 is equal to V2 upon T2. We can take it as a constant. We can take it as a constant. Then our equation becomes V upon T is equal to constant. V upon T is directly proportional to 1. When we remove proportionality constant, then there will be sign of the proportion, and we put T over here. Then our Charles law is proved. V is directly proportional to T at constant pressure. Okay. Thus, the Charles law is also stated as the volume of given mass of gas is directly proportional to its absolute temperature. Absolute temperature at constant pressure, and absolute temperature means temperature in Kelvin scale. So thank you so much for this video.